Bismillahirrahmanirrahim. Assalamu alaikum. I am Inqilab Patel, your computer science teacher. We have learned a number system in which we use 10 digits. Then why do we need binary numbers? This is our today's topic.
There are input devices that take input from the outside world and convert it into binary information. There is memory to store this information. There's a central processing unit, or CPU, where all the calculations are done. And finally, there are output devices that take information and convert it into physical output.
When you press a key on your keyboard, let's say the letter B, the keyboard converts the letter to a number. That number is sent as binary, ones and zeros, into the computer. The CPU requests step-by-step instructions from memory which tell it how to draw the letter B. The CPU runs these instructions and stores the results as pixels in memory. Finally, this pixel information is sent in binary to the screen. The screen is an output device.
There are zeros and one. Here is 0 is and 1. This number is transmitted from mouse to CPU. This is our CPU. This is storage device. Right? Like a data which is transmitted from keyboard is also in the form of zeros and 1. From our camera, from our micro, using any input device is in the form of zeros and 1. And we can see that the output is also in the form of zeros and 1. Either this is a picture, a text, everything is in the form of zeros and 1. It means whatever data is transmitted between different parts of computer, or whatever data is in the process in the CPU, is in the form of zeros and 1. Means there are only two digits, you may see 0 and 1. Current signals. These are current signals. And we have only two types of current signals. If we see the current signals, we have only two types of current signals, on and off. On is represented by 1 and off is represented by 0, and you may see that there are only two digits. As there are only two digits, we say that this is a number system in which we have only two digits. This number system is known as binary digits. Like if we want to enter alphabet A, this alphabet is firstly converted into zeros and 1. 0, 1, 00, 000, 1. And then it is being transmitted inside the computer. If you want to enter, this is basically equals to 65. If you want to enter a letter B, this is equals to 01000010, and this is actually 66 in our number system. In our number system we have 10 digits, so we say that this is decimal number system, or we say that this is denary number system. And in computer we have only two digits, so we say this is binary number system. Or binary digits. We pick the by from binary and t from digit, and we say it bit, means 0 is a bit and 1 is another bit. We have only 2 bits in this number system. You may see that whenever we want to input B is converted into binary 0 and 1s, and then it is transmitted to CPU. CPU works on this data, and then you may see that the data which is sent from CPU to monitor is also in the form of zeros and ones. Here 1 represents on, means white color, as the picture is in black and white, and black represents of, means black, right? Here you may see that there are only 2 colors. As there are 2 colors, we say that this is a black and white image. The colors of black and white image is also represented by binary bits. White is represented by 1 and black is represented by 0. If we are using grayscale image, in grayscale image the colors are also represented by zeros and 1. You may see in grayscale image we have 4 different colors. One is white, one is light gray, then dark gray, and lastly the black. White is represented by 1 1. Light gray is represented by 1 0, dark is represented by 0 1, and black is represented by 0 0. Means we are using 2 bits for each color. Here are 2 bits, here we have used 2 bits, and here we have used 2 bits, and there are 4 colors. Means if we are using 1 bit, there will be only 2 colors, black and white. If we are using 2 bits, there will be 4 colors, right? And if we are using 3 bits, we will obtain 8 colors. Basically this is 2 power 1, that is equal to 2, this is 2 power 2, that is equal to 4, and this is 2 power 3, that is equal to 8. In computer we may use up to 24 bits for colors. If we are using 24 bits, then we can represent each and every color which is present in our nature, in our environment, and we will obtain more than 16 million colors.